everything, I can run everything in the same manner. The same manner, it means, first of all, I declared a stopwatch class, instance of stopwatch class. Stopwatch class can calculate a time of code, of execution of code. If I run a method start on the stopwatch instance, the calculation started. If I run a method stop, the calculation is stopped. And sy variable, stopwatch variable, remember a time which execution took. Then, when I started the stopwatch, I start a method run on process. Process is a variable, as I told you, with a type I process. This method in this parameter, this is a parameter of type I process, and in this parameter, I have put it in the first step serial process, in the second step parallel process. I will explain this part of code later in few seconds or few minutes, few seconds probably, in the 1 minute. And when the run method, I remind you that the run method is here and here, is finished, then the run method returns red value to serial process method returns red value, and parallel process returns the same information, calculated in different manner, of course, because one method, one class, first class, serial class returns, calculates everything with serial process, with linear process, and parallel class return calculate everything in parallel process. And after an execution, we get a red variable. And next, we print something on the screen. The process name, time which elapsed in milliseconds of time of calculation, pi value calculated by pal value, and the error difference between expected pi value and calculated pi value. And additionally, I have put it a number of points. Every points and points inside number of points inside a circle. And for later calculation, we have saved elapsed time in a runtime variable of a process. Okay, it's our auxiliary. It's our auxiliary method, which we will be used to calculate our pi variable, and to print results on the screen. Results, it means the pi value, time of execution, and similar things. Then let's come back to main method. In the main method, as you remember, probably, as you should remember, it's the method from which the program starts his own execution. If you are starting debugging process, or if you are running an application, the main method is the place where program starts execution. First of all, we have made serial process instance. Serial process, I remind you that this is a class serial process here, defined on the previous slide. Next, we define the number of iterations. In this case, it's 1 million iterations. Next, we have printed expected pi value on the screen, because we would like to compare expected value and calculated, estimated. Next, we run the process. Run the process method is here, I remind you. To run the process method, first we are putting serial process instance here. and number of iterations. If we run it, I remind you that on the process we started method run, and number of iteration is put to the run method. Okay. The run process prints results on the screen, of course. Then next is the second part of our calculation, the parallel process. Here is an instance of parallel process. We hold the instance of parallel process inside a variable parallel process. Next, we run everything again, but we have put it parallel process. In the previous example, we have put it serial process and the same number of iterations. And it's all. And as a final information, we compare on the one line runtime time of execution for serial process and time for execution for parallel process. It's all. And as a final line, right line is printed on the screen. And I remind you that readk allow us to stop execution of a code. And waiting with the console opened to the results. Okay. Stop execution. If you remember the previous lecture, you remember that we have two types of parallel processes: foreground process and background process. Background process maybe in different manner. The application will work as long as at least one foreground process is working. And our readk method is waiting, it prevents to stop working our foreground process. If we have a background parallel process, then it's the possibility to waiting for finish our background process. Our background process can finish because our foreground process is waiting. If we would like to click a key, our foreground process goes forward. It means it goes outside of main method. Then it means that our foreground process is finished, and in this case, each background process is finished too. It isn't important if it finished its work or not. It's finished. It's stopped. It's killed, and everything stopped working. Then, in our case, it's important to have readk method, because the readk method waits for action from the operator. Action, it means that operator should click something in the keyboard, then program can go forward in this moment, then can finish in general. It was explained, as I remember. Oh, maybe it wasn't explained during the previous lecture, but it's explained in the instruction for the laboratory. Okay, then we have started our program. We started. One screen more with a CPU utilization. On the left side, we have idle CPU. It means that it does nothing, almost nothing, of course, because you can see that processor can have something to do. It's some kind of operating system processes. It takes power for operating system processes for some kind of services and similar things. We can assume that this low utilization means that our computer do nothing except, as I told, except system operations. And on the right side, we have on the top screen, in which in the first part, in the first half, we have utilization in serial process. It means that normal for loop is working, but second half of our screenshot, it's the utilization for parallel working. And as you can see, the utilization, the power consumption is bigger, is almost 0.5%. It's almost 0.5% in the parallel process. In serial process, it's something like 30–40%. And one thing more, in parallel process, we can see that each core in my computer during this experiment is used. By in the serial process, it is in situation in which one core is used and the rest of cores are waiting. No, the operating systems decide which one core should work and in which moment. It means that every operation can be put in every operation on the hardware level, we can say. On the hardware level, it can be put to the different core. It depends of something. I don't know. Maybe it's hardware decide because cooling of a processor or something like this. But in general, we can see that utilization isn't very big, but each core is working. The right core is working harder, the left core is working easier, but we can see that each core has something to do more than in the idle situation when the utilization is very, very low. Okay, there is an example that there is difference between linear operation, linear process and parallel process. Then it's evidence that we use more computation, we consume more power. Then I think it's good because we can think that everything is going correctly, but oh no, something doesn't happen. Something goes wrong because for the serial process, our pi was calculated 3.14 and something. But for parallel process, we can see that pi is equal 0.03. Oh, it isn't good. It isn't good. And as you can see, everything looks good, but everything looks good in the first look, but it isn't good. Our calculation of pi isn't correct. The error is in the first case is very, very small because first three places is equal 0 after a period is equal after a comma is equal 0. But in parallel process the error is equals almost 3. It isn't good. The next one thing, I will come back for one moment here. No, here. Yes, here. As you can see, in the brackets, there are count and count in. Then there is a number of points, and here is number of points inside a circle. As you can see, in the serial process, we have 999, almost 1 million points without the one, which is expected, as you remember, because we have lower than, not lower or equal number of iteration. 785,000, more than 785,000 points inside a circle, but in the parallel process we had only 6,000 inside the circle. It's surprised for someone which doesn't expect the situation. And one more thing, that parallel process took more time, 4 times more than serial process. It's surprised. It can be surprised too. It can be surprised too. Okay, let's repair something. Let's repair something. First of all, again, I remind you one thing. If you remember this slide, you know that a parallel process can make some kind of unexpected results. This slide. Let's come back to our code. Okay, and in our case was the same, because our number of points is lower than expected number of points, then we can think that there is similar situation like in the previous slides. What we can do? We can block access to our variable. In our case, I choose interlocked increment method. Interlocked increment method in our case is able to block access to the count variable, increment it, and unblock access. The same with increment count in. It's the same situation. We used interlocked increment and run everything again. And after we run everything again, we can see that number of points is correct. Number of points inside a loop isn't correct because it's 10 times slower than expected for parallel process, of course. For serial process, for linear process, everything looks good again because number pi, estimated pi is 3.14 and so on. The error is very small. The error is very small, but something happened again with our calculation of number of points inside a circle. One moment. I would like to check something. I would like to time how much time I have in our presentation. Okay, what to do? We have to repair it again. We have to repair it again. And during investigation, I understand that the problem is with our random method. I remind you how it looked earlier. Our random method was declared on the method level. Excuse me. Our random instance was declared on the method level. It means that every iteration, each iteration from our parallel for had access to the same instance of our random class, of our random instance. I remind you that random R&D variable holds allow us to get random numbers, and each instance of our loop had access to the same instance of a random variable. And I expected that I investigate that there is a mistake. There is a mistake. Then I moved the random instance inside a parallel for. It means that every iteration of our parallel for had own random instance. It means that 1,000 of 1 billion of instances of random classes will be produced during our process. In case of linear process, we can stay with one random instance. Then we can expect that time of operation in our parallel code will be longer because we have to create new instances for every iteration. It was longer than serial process. We saw it. But oh, now you can see that something changes because time is 3 times longer than the previous process, and in general 10 times longer, more than 10 times longer than serial process. But it was a solution for our problem. As you can see, currently we have almost 1 million points, whole points, which was in 1 million numbers, and inside the circle we have 784,000 points, and similar value is inside in the case of parallel process. Then it means that the results are almost good or are good in general. As you remember, the previous example show us the error. The error was for serial process something like 0.0004. In this case, the error is the bigger in general, the bigger than the previous error, but we can say that it's accepted. Of course, you can think that 3.13, oh, it isn't good, but next number is 8, next number is 9. It means that we are very near 3.14. And the same situation is in the parallel process. The calculation is in the accepted quality in general. Probably if we would like to add more points, then maybe results will be better. But it isn't important in general in this case, because we can see that calculation of serial and parallel process gives us the same result. It means that everything was calculated and everything works in good manner, except a time of execution. As you can see, serial process is 10 times faster, 10 times faster than parallel process. Oh, and I have a special slide with Luxon. Are you here? No.
Yes,
Yes. Do you see the young child?
Yeah, I'm looking at the boy. Yes.
This white boy. Maybe I should put the black boy. It will be more comfortable for you. But where is the benefits? Where are the benefits if our serial process took less time? I will show you. I added the sleep, some of a sleep to our methods. Of course, you don't have to think that you should add a sleep because it will be better, because it won't be better. But our sleep method should simulate longer process, not only fast calculation of generation two random numbers and short easy calculation, multiplying, summarizing and multiplying. But our calculation should take long time. The same time, sleep and 1 milliseconds in general. And as you can see, the time of execution was changed. For serial process, it took 15 seconds. 15 seconds. I added only, I can say 1 millisecond, but as you can see, it isn't true. I will explain in a few seconds. And parallel process took only 2 seconds. It's 7 times faster. Make calculation with parallel than serial process. One more thing which you have to see, that we executed only 1,000, not 1 million iteration. Then is the reason why the results aren't good. But I wanted to wait 15 seconds multiplied by 1,000, because it's a lot of time. Then I changed it to 1,000 iteration. But as you can see, we added some small time for waiting for the process, for make process longer. 1 millisecond multiplied by 1000 should give 1 second, not 15. It means that creation of sleep, generating processes inside a sleep method took something like 15 milliseconds. If our sleep took 15 milliseconds, then multiplying 15 by 1000 gives us 15 seconds in general. Then you can see that operating system, processor, and similar things took sometimes for execution infrastructure. But again, as you can see, if you have long-running process, it depends, of course, how long. You have to probably calculate it or analyze it or make some kind of experiments in this situation. But for long-running process, the parallel process is faster, a lot of faster than serial process. For short processes like here, the serial process is faster and easier because the code can be easier. In our case, it isn't very complicated, but the more common is for loop than parallel for method for some people. Then again, as you can see, for long-running processes, the parallel process is faster. In our case, more than 7 times faster than serial process. There was a use case in general, case explanation of the situation in which I showed you some kind of troubles connected with a parallel coding, with a code which should be executed parallel. And I explained you the ability, the needs of code, why we need a parallel process, because our code can be executed faster, and we can use resources of a computer in optimal manner, and we can get results in shorter time. But of course, with troubles, with a more complicated code, with a more complicated tests and similar things, with a bigger risk, Okay, some kind of few slides. I don't know. I have 5 slides of a short theory. The process is an executing program isolated from other processes in the same operating system, and so on, with the data separated and can be started and stopped independently and similar things. But sometimes, and very often, I think I use process and threads in the same meaning. Then common meaning of a process is a thread in general. Then please forgive me if I will say that we have more processes or background process or similar things. In general, the definition tell us that process is a program. Multi-threading is an ability to run many more than one threads in the process. It means that if you are able to run more threads in one program, it means that it's multi-threading. Thread is a set of instructions executed independently from other threads. In our case, here is a thread. We have a lot of threads. We have 1 million or 1,000, depends on the example. Threads which can be executed independently. And next one, oh, foreground threads. I told you that you have to remember, but you couldn't remember because probably is here, not in the previous slides. Foreground threads is the application runs as long as the as foreground threads exists. And I told you in this case, one were here. And I told you that you can hold foreground threads as long as the user clicks some kind of key with this method, because this method can read a key which was clicked by the user, and there we have a background threads. We have a background threads which are running in the background, which runs in the background. It means that we have to have more threads which works in the background and which returns us results. As it means to the thread which call the background threads. Next one, we have priority, highest above normal, normal below normal, and lowest. It means that threads can have different priorities. In general, we won't use in our exercises the priorities, but you have to know that there exists a possibility to change a priority for the thread. It allows you to run some kind of execution earlier or later, because operating system first run the threads with highest priority. Next, if the highest priority is finished, with a threads with highest priority is finished, runs the threads with a lower priority from the top to the bottom. And if the higher priority will appear, the thread with a higher priority will appear. The lowest priority, the threads with a lower priority are stopped, and the highest priority is the thread with a highest priority is executed. Then the priorities can be important in some kind of situation, but in general we won't use it. And last slide in this presentation, we have 4 types of parallelism. Bit level parallelism, which is connected with hardware, especially with hardware. The instruction level parallelism, which is connected with low level instructions. But we will work with task parallelism and data parallelism. Data parallelism, an example of data parallelism was presented a few minutes ago, but in the future we will have more examples and more constructions, and we will have exercises during laboratories. The task parallelism will be explained in the next part of our presentation. We have 20 minutes. We have 20 minutes more. Then task parallelism will be explained, and in the next laboratories we will have an example. You will have to make an exercise with a task parallelism. Okay, I'm changing a presentation. This presentation is finished. Where is my presentation? Here is. Okay. And we are trying to, I'm trying to show you something. Okay. Task parallelism. We have 5 methods to show to run a task in different thread. Probably first two examples we won't have during, yes, probably we won't have it during laboratories, but we will have background worker class. We will use a background worker class. And now, because we have less than 20 minutes, I will explain you background worker class, and next I will come back to thread class and thread pool class. There are how to say, there are elements of lower level of an infrastructure. The background worker used this kind of elements, but gives you more functions, gives you more possibility. And I would like to propose you to listen carefully, because we will have exercises in the next laboratory from it. One slide of a theory, next slide will be with a code, and code will be explained by me. Okay, background worker allows you to release the main thread. It means that you can run some code on the background thread. Code can calculate something, do something, executed something, but in the same time you can do something else in the main thread. It's very good option, like a parallel processing, because it's parallel processing. The thread can be created and maintained by common language runtime in an optimal manner. Oh, it's information for you, for programmer. I don't know if it's useful information. It's only important to know that everything is made for you. You made only some, in general, easy code, but for the first look, this code can look complicated, but it's easy. It's easy to understand. The exception handling is built in. In the previous examples, thread and thread pool doesn't have don't have thread and thread pool don't have exception handling, but background worker has, and background worker support progress reporting at thread cancellation and termination. It means that you can stop it. It isn't that you run it and forgot, but you can control the work of it. Control, it means that you can stop it, you can receive results and similar things. And like for each parallel code gets more complicated, harder to debug and maintain, because as in the first example presented today, the parallel threads can work in different time. It's difficult to synchronize it and similarly. In general, it's harder to understand, to debug, to mind, and it's more complicated. You have to understand more. Okay, and example, I will explain how it works. I believe that you will understand it, because in the laboratory you will use it. You will have to work with background worker more with, I can say more, because you will use more than one background worker in the laboratory. Okay, the background worker is the class defined in the .NET framework. Oh, I can see something like this. It's the class defined in .NET framework. To use it, you have to make an instance of this class. With the new word, you create a new instance, new object, which is held in the variable. In our case, variable has the same name, but with the small letter, not capital. Capital is the definition of a class. We have used small letter to the background worker. As you remember, the C# is case-sensitive language, then you can do something. It's for the computer, it's two different things. And the most important thing which you have to know and remember is that the background worker can run code in the background thread. How we can do it? We can attach a method with a special signature, I explain in a few seconds, to the property do work. Our background worker has property do work, and we can attach to this property. It's called a delegate in general, but you don't have to remember in this moment it. We can attach with a syntax plus equal the method. Method should have a special signature. It means that the method can has different name, but it has to have the structure, the similar structure. It means that the method should return nothing and should get the object, the variable of object type in which we will hold in which will be holded a background worker. I will explain it. And second variable of type do work event args. This type is defined in the framework too. You don't have to define it. It's defined. And if you have this kind of method, it can has of course different name, but the signature of this method should be the same. You can attach it to the property, to the do work property with a syntax, as I told, plus equal. Okay, it doesn't mean that the method is running in this place. Not. This method will run if we will execute the run worker async method contained in background worker. In the situation in which we run this method, then background worker will prepare everything for us, will make everything which is needed to run a method in background thread, in second background thread. Which method will be run? The method which is attached to do work property, as I told. It's all. It's in general all. These three things, 3 lines of code. One, this line, and this line. This is the 3 lines of code which you have to remember to run the background worker. Yes, then as you can see, there are more lines. Then I will explain what's going on. The first line, we can turn on or turn off the information about a progress. If we would like to inform the main thread about progress, you have to turn it on. It means we attach the true value. We made worker reports progress property, we set to true. The same with the support cancellation. If you would like to pass information about cancellation of a background thread, if you would like to stop working our method, we have to set true to the worker supports cancellation. And next, if we have worker reports progress to set it to true, we would like to get information from the background worker in some manner. And how we can do it? We can define a method with a signature like this, presented here. The method should return nothing. The method should take as a first parameter object, the variable of type object, and the second parameter, progress changed event args. The parameter of a type progress changed event args. As you can see, in the E variable, we have property progress percentage, which holds a progress. And we can do something, example, print on the screen, like in this example, or pass the variable to different part of code to inform a user example or do something in this time. It depends. It depends on your application. But from how the background worker knows what kind of progress is, there is reported inside a do work method. As you remember, the do work method is a method which is working in the background worker. The code contained in this method is working inside a second thread in the background. How we can pass information to the progress changed? First we have to get a sender object. The sender object contains the background worker. And we can, but there is a type of a variable object, then we have to convert our sender object as a background worker, and we save it in additional variable. The var word means that we have some type of variable, which kind of type? Read it from the right side of an equation. In our right side of an equation gives us information that we have background worker type. Then the variable worker will contain the background worker variable. And next, if we would like to pass information about the progress, we have to execute a method report progress. And to the method report progress, we have to pass some variable, some number. Number, as the name of a method tells us, report progress, it have to be passed a number which is equal to the state of a processing. Example 10, 12, 15, and so on, depends on a progress of a report. And when we execute this method, the worker will process it, will take it from the background thread. It will take it from the background thread and will put it to the progress changed method. It looks complicated, but it isn't in general, because we have attached the progress changed method to our background worker, and background worker knows how to transfer it from the background thread to the main thread in general here. Next one, information that the console is thread safe process. The console is thread safe process. You can think that you can put here the line console right line and do something. It's true, because the console is thread safe, but not exactly. You can do it with different types of user interface, example of different type of code and similar things. Because if you would like to move your data from background thread to main thread, you have to use this method. And one more information, because we have only 5 minutes, then probably I won't be able to explain more. The same situation is with reporting of finished. If you would like to report the finish of task, we have to declare a method like this one, work completed, which work completed or with different name. Name, it isn't important. You can use different type of name, but the method should return nothing, but should input as a parameter object, which is the worker, our worker. And second parameter, run worker completed events args. Run worker completed event args can hold result variable. Result variable is taken from a result variable from do work method. If we will pass some data to the result, that this data from this place of result will be passed by background worker to our work completed, method and we can read it. It means that we can send in safe manner data from background worker, from thread which is running in the background, to the main thread. And it's important to know about it, to understand that you can't do, you shouldn't and you can't to move the data between the threads in general. It isn't important if it's background or not. You can't to move in easy way data between threads. Of course, you can try do it, and sometimes it works, but sometimes it gives you some kind of unexpected exception. Okay, 2 minutes, very short time. I believe that you are able to analyze this kind of code, except information about finishing. Yes, I will give you. Presentations. Right. We are able to break a process. If we will run a cancel async method on background worker, if we will run cancel async method of background worker variable object in general, then this background worker will inform our method that worker cancellation pending. If worker cancellation pending will be set to true, we have to stop everything. It's all. It's all. Then we can read information from worker if someone set cancellation async, someone run cancellation async method. Then background worker communicate everything for us. We have to only use available methods. In general, is everything. If you will have a question during laboratories on the beginning laboratories, because the next laboratory will you will work with this kind of code, then please prepare a question. If you would like to receive explanation again, I can give you 5 minutes, 10 minutes during laboratories. It can take, and I will explain again. But probably I will explain again how to pass a variables. Not again, I will explain, because I have one more slide with a passing of variables from the main thread to the background thread. It's all for this moment. Rest of a presentation I will make during a next lecture. If you have question, or you would like to have a presence, if you was absent on the beginning, please stay here. Thank you for your attention, and we will see in the Monday, I believe, in the different classroom. I saw that we have 202 classroom. I remember that there are computer maybe better than in the last laboratory. Thank you. Someone stay here, please put your hand up. Yes, where's one guy is waiting. Please explain what you. Thank you. Bye. We will see in the Monday. If you will have question, please analyze the code, and we'll talk during laboratories. I will give you a presentation in few minutes. Mr. Liberty. Mukubvu. Mr. Liberty Mukubvu. Thank you, Mr. Luxon. Oh, Miss Liberty. Sorry.
Yeah,
yes or
Miss
not? What?
Liberty Mukubvu. Liberty Mukubvu.
Liberty Mukubvu. Mukubvu.
Yes.
Yes. Okay. Okay. I understand that you would like to have a presence.
Yes, sir.
I can see you.
I'm here, sir.
One moment, because I have to find. Oh, I have the list here. Okay, thank you. The next one.
Yes, reward, Edoyibo.
Reward. Do you?
I can turn on my camera. Yeah.
Oh, I can see you.
Yes.
Better quality. Oh, very good, very good. Thank you. I can see you. Please stay with me. Give me a chance. Please give me a chance to write your presence.
Here I am. Not going anywhere.
One moment. Edoigbo.
Yes.
Yes, Edoigbo. I'm trying to learn your pronunciation of your name and surname, and I believe that every time my pronunciation is better and better.
Yeah. Before the semester ends, you would get it right.
Thank you. I wrote your presence. Who is next? Mr. Martin Silumesi. I can see you. Martin Silumesi. You have to turn on your microphone. Oh, it's better. It's better. Where are you from? Zambia. I asked you about it. Did you ask you about your? Where are you from? Because I remember when we talk about practice. Yes. Yes. Zambia. Okay. Very good. Okay. I gave you a presence. Thank you.